Is it audible now? Yeah, I think initial hurdle is over. So good morning once again. We will wait for a couple of minutes before starting this webinar. This image on the screen beautifully depicts the rising of the robotics. Moment, I think. Yes, good morning once again. This image on the screen beautifully depicts the rising of the industrial robots, where a mobile robot is looking up to a rising sun and to the rising robotics for industrial automation and the next revolution happening on the robotics. We'll wait just a few seconds before starting this webinar so that all the attendees join. A quick introduction of myself. I'm a co-founder and CEO of Apurva Technologies Private Limited. LinkedIn and Twitter handles are displayed. You're most welcome to connect, follow, and share your experiences on the industrial robots as well as anything to do with technology, because that's what we love every day. Uh, Once again, good morning, and we'll start the webinar. The agenda or the outline of the webinar is as follows, where we will have the state of art. What we have done as a part of team at APME, we have compiled some videos which depicts the state of art on today's scenario on robotics. That will give a sort of some sensation in terms of starting or setting the tone of the webinar. Uh, then after, we will actually go on to the robot types and selection and integration. Uh, how do we do that? What skills are needed to do that? Uh, all the things with robots, what is coming up, including the path forward and opportunities, not only for engineers, but all these streams, such as management, costings, accountants, finance, and so on, and followed by a conclusion and Q&A. We'll have this webinar is a listen-only mode, so any candidate kindly request to put question and answer tab so that we can attend at the end of the webinar. And if we miss out answering any of the questions, we'll get back to you individually as we've got your registration IDs. Moving forward, these are videos taken from some of the leading companies as well as leading integrators outside in the industry. So we'll quickly run upon this. I might go forward just to save time on the videos, but this will show you how today's world, the automation is happening and how people are using the robots. So what we see here is a Ford manufacturing unit where the headlamps are being adjusted by a collaborative robot. And this is the so here the robot comes on some of the accessories or the ancillaries where, so I think the important part to show here is robotics is not just the robots. Robotics is the subsystems. Robotics is sensors. Robotics is the integration of what all you see on the screen, as well as human interaction, where a person attends with the robots, along with the systems, cameras, and adjustments. So what you see on the screen is a robot adjusts the focus of the headlight on the car by adjusting along with the person operating the vehicle or the setup. So this brings a safety aspect as well, where people are working within the robots and using the technology along with it. I'll just move forward to a next video, which is pretty fascinating in terms of the flexibility and the diversity it is handling. Uh, this is by a company called ABB Robotics and a New Tech Limited. This is, of course, taken from YouTube's, but this depicts the flexibility or the speed and the type of robots you see acting fast onto the food grade items. So these are sandwiches, cheese blocks, chocolates, and everything. So this shows speed, accuracy, agility to handle food items, making sandwiches into the speeds required, and as well delicate to handle the food items. So it's not always about industrial items. Handling food grade products is also one of the leading area where robotics are used. Now, all these, how do, if someone wants to make this or handle this, what all things needed, which we will cover in the next few slides. Now, in solving these problems, there are many skills needed, which we will see. This is one of the very fast robots, which takes the cheese cubes onto a conveyor, a feta cheese manufacturing unit. We'll go on to a different type of robot, which we call mobile robots. And the mobile robot is the moving type of all-wheel robots mounted with industrial robot. That becomes a very sweet combination of industrial as well as mobile robots, which will do certain operations on the parts which are very big. So the robot cannot move. It is moved now on a table or on a vehicle, what we call AGV, automated guided vehicles, or automated mobile robots. Today's webinar is limited to industrial robots, but this depicts integration of many technologies together. So there are grippers, there are machining or material removal process, there are sensors, there are safety sensors, and there is a shop floor process. So all these depicted well in this video. What looks like a good solution on the video, there are a lot many hours gone inside making this solution. So I'll just go on to the next video, which is upcoming future of robotics, collaborative robots. And this collaborative robot has got two hands, which depicts like a human hands. It's safe to operate.
The UV is about so much more than just eye-catching photographs. For industry, the advent of a truly collaborative robot working alongside human staff has been little short of a revolution.
So the robots work with human operators, safe, so operators don't have to stay behind the cages.
Ergonomic human-centered design, padded arms, and motion control software can be installed in workstations alongside people, working collaboratively on tasks with human colleagues. And lead-through programming means it can be programmed in minutes by someone with no specialized training. That all makes it ideal for material handling and assembly jobs, while its accuracy has meant UMI has found a place in medical research too, increasing hygiene and efficiency. The UMI family has continued to grow. The concept of a mobile UMI has been tested.
So now the collaborative robot mounted on a mobile robot makes it more effective. The last video onto the making the setting the tone for the webinar is a packaging unit making packaging noodles onto the boxes, which is very fast. This type of robot will cover onto the following sections. This is pretty fast. and solving the packaging needs of the industry. What you see on the screen is there is one robot operating something, but also you should see all the sensors blinking around, all the conveyors, conveying systems, and the control system commanding this. You would see a lot of motors, conveyors, sensors outside on the back end where my cursor is moving. So not many things go along with the robotic solutions, and we'll cover what it is. So I think that sets the tone, and we thank you. We thank the YouTube videos for allowing us to show this. Uh, Typically, industrial robots, there are four major types around for any robotic solutions, starting with the gantry on the most right hand side, which is the 2 or 3 or 4 axis solutions, a primitive but widely used known robotic systems. Delta is one type of robot which is mounted uh, on the ceiling, which is around 5 axis, 4 axis to be honest, and then SCARA are in around 4 axis, and articulated most left the robot, which is representing articulate human hand-like motions. So we will basically cover all these robot types and how to select, want to select, when to select, and which is the major point on this webinar. So, and before going to that, we will also cover some of the mobile robots in next webinar sessions. And it is interesting. So this is just to keep the sensation going on, that these are the types of mobile robots now available in the market for various applications, starting from food to video calling to hospital sanitization to warehouse moving to inspections and material moving and so on. So this becoming a newer market now, where the onslaught of mobile robotics is happening. And when industrial robotics is attached to mobile robots, it opens up a whole new opportunity for the market out there. So this is just to set the tone. On the robot selection, we have divided into a very basic aspect, and I'm sure if the audience looks at the way we are looking at, because of our experience of integrating a lot of robotic solutions, how do we approach from a ground zero upwards? So the first criterion is application. That's where normally a robot selection starts, which is the environment. So the environment, I mean, we have, due to space restrictions, we have listed only 4 environments, which is hazardous or dusty or EMI free, which read the electronics assembly plants, and the clean room, which is the pharmaceutical most uh, difficult because of the current crisis of COVID, where the virus or the drugs have to be contained within a requirement. Now, why environment comes first? Because if we move to the, I mean, if we just remember the first slide, what type of robots, some of the robots may not come with that configuration. So when we say configuration, if it's a clean room requirement, not all the robot types come with the clean room settings or clean room ability, or and the EMI free. It is the electronics. No, so no, all not all the payloads or not all the sizes come into that configuration. And when it comes to hazardous, which is a nuclear or a very high temperature areas, not all types of robots can operate. So the first thing what we would recommend to go is to take the environment or note down the environment where we go. So if you are designing, if one is designing a solution, if one is maintaining the solution, one is supplying the solution, so we are looking at all audience types. So it could be a designer, he could be a manufacturer, she could be a service, or she could be a marketing person. So now all of these, the first thing we look at is the application. The second, of course, the important part is the payload, uh, which is the weight. So, I mean, typically, I mean, there are many aspects to a payload, and we will cover the in-depth on topics on the payload and the application on upcoming webinars, because this is the series of the webinar we are doing totally free. The weight, by weight we mean the product to be handled. So if we just remember the videos we saw, the product could be noodles, the product could be food items, the product could be knife, because that robot was cutting the cheese blocks and the chocolate cakes. So that product was the knife and the gripper and the accessory. So if we remember the mobile robot and the industrial robot machining and polishing something, the gripper had the weight, gripper had the sensors, and the product was being handled was the machining operation. So the first is application, second is payload. The third, very important, is the speed. Now, these are all required before we go on to the selection of the robot. So on the next slides, we'll show you how do we handle these applications typically in the industry. But the speed, which is the line speed or the product speed being handled, so the products moving onto a conveyor or the products coming to the robot, such as the cars assembly, the activation speed, how fast do we need to act with the gripper or with the robot or with the human. What is the, now this is very crucial and which is not known to all fraternity of engineers, is the communication speed. Now what do we mean by communication speed is how fast do we need to communicate between sensors, the control system, and the robot itself. So how do we handle the speed operations? So one is the line speed, so let's not get confused with the communication speed. The communication speed is how fast do we actually need this application for. This decides a major selection, because some of the robots may not come. I'll come back to the speed portion in a while. So some of the robots cannot communicate faster, because not because of the speed of the robot or speed of the mechanical thing, but the speed of the communication and the subsystem speed. When we say subsystem, all the videos showing that robot was not alone. It was accompanied by conveyors, sensors, and many more things. If they are slowing the speed down, that should be accounted for. So all these four speeds, when we are looking at, will define the overall solution speed, and individually everything has to be taken. And again, touching a point that should go back to the payload, because a speed is also related with the payload. Higher the payload, lower the speed, which is obvious, and lower the payload, higher the speed, which is also very obvious. But again, that depends on the type of grippers used, type of accessories used, and the communication used makes a selection proper. Uh, a good idea is how would you actually mount the solution. So I'll just take this screen away. Just a moment. So the mounting condition is the space required or space available, a floor condition. How is the floor condition? Is it ready to take the robot on? If the ceiling is capable to take the load, if the ceiling is available there, is it a high roof system or is it a low roof system? Are the tables available where we can put it? Can we invert the robot, or can we do a mobile robotic system? So the mounting condition also decides. I mean, what we're talking is solving the application. If we are designing a greenfield plant where we do have a lot of flexibility and freedom, then also this becomes a very important point, because space is very premium nowadays. We are looking at less and less space for manufacturing, better maintainability, less number of parts, less complicated systems. So space requirement has to be taken care even in greenfield, or where designers and the suppliers have got all the freedom to design as large setup as needed. So this becomes one of the critical parameters for selection of the robots. Now this may sound very silly, but take it from the experts that these are the points. If we take one by one points, select the proper options in this, we will get a proper robotic selection. And this has been a proven system in the practice. The next is related with the speed is the communication protocol available. Now, what happens? This is a a mixed engineering or mixed branches of engineering joining together here, where we have the PC and the PLC interface or subsystems. How do they talk? So when we say communication protocol is the language of interfacing, language of automation. There are many protocols. Of course, we'll not go into the detail, but these buzzwords are to be kept in mind that if there is a Profibus, Profinet, TCP/IP, or any custom protocol to be used by robotic systems, it has to be available on the PLC and the PCs and the accessories and the ERP systems if the ERP system is going to connect with the robot. Now, I mean, if we are asking to a robot manufacturer or a robotic system integrator, they would have all the tools to integrate different communication protocols. But the robot itself, the type of robot may not have, or the brand of the robot may not have all the communication protocols available with them, which might limit the selection of the robot. So, just going back to the memory, if a SCARA robot has to be used, there are n number of manufacturers out there. Not all offer Profibus, Profinet, TCP/IP, and so on. So we are not particularly aiming a brand, but this becomes a limiting factor when we are deciding a robot as well as a PLC system as well as the accessory systems, because of the choices of the manufacturer, choices of the end client. For example, end client ABC would always recommend using brand X, Y, and Z. Now, that brands X, Y, and Z may not have all the Profibus, Profinet, TCP/IP, and so forth. So that the brands will be limited, the selection will be limited, type of robots will be limited by the communication protocol available. Uh, the next is the IP rating, where of course this goes along with the application environment, which is the dust and water resistance. But this also makes some difference in terms of where the product is designed, where the cell is designed, where the whole solution is designed, what level of IP protection we need for a robot and the controller. If that is not available, which will limit the use of that particular type of robot. So even if everything else is ticked off, but if the IP rating is not ticked off, we may have to change the robot selection. Uh, a good point is the positional accuracy, which is the repeatability and the accuracy versus speed versus payload. Now, this is also a sort of iterative process where we want a particular accuracy. So just let's go back to the memory lane, the food products which were being handled. You won't like if the your feta cheese or pizza is not cut as a particular triangle. So that becomes the repeatability, how repeatable and it might. So let's say food item, you are okay with this, but if it's the machining operation on the industry, you want it to be accurate. So the positional accuracy becomes critical parameter against speed. So now we are interacting within the speed uh, and the protocol speed and the IP rating and the payload and the application and everything together. Uh, the last but not the least, how would you, the new buzzword, collaborative robots, speed versus safety versus guarded robots. So it's a big debate out there, and I think we'll need about more than 10 webinars, 10 hours long discussion of collaborative, high collaborative, guarded robots or the normal industrial robots. Why that? And safety versus speed versus ROI. So giving the whole picture, starting from application that goes on to IP rating, payload goes on to the accuracy and the safety and the protocol speed, and speed being intertwined with the communication protocol and mounting condition. So all these put together makes. So if anyone wants to select a basic thing on any automation or the robot selection, these are the 8 parameters where we would start. Of course, this is just this webinar is just the outline or the introduction. There are a lot of details on every point. There are a lot of ifs and buts and a lot of iteration on everything, which we will cover on upcoming webinars. A quick recap on the type of robots we just saw on the first screen, where we would say the speed when we say these numbers, these are ticks per minute or the operations or the cycles per minute, and these are just a representation. So we would find exceptions on every type of robots where, for example, SCARA robot can go up to 150 peaks. Delta robots can go up to 280 to 300 peaks. Now that depends on the solution and the speed of the communication and the speed of the conveyors and many other things. So it's not just the robot alone there. When it comes to the payload, these are the industrial robots. They are absolute winner where we can have as large as 1300 kgs and beyond on the industrial robots. Generally, for the food items where the weights are less than 20 kgs, we are talking 200 grams to 1 kg. These are used. Of course, at very high speed, so the weight reduces down. The same thing with the SCAR robots, and the gantry are the most primitive in nature, but the cost is low. So when the cost comes, gantry becomes the winner because both these robots now, cost is again a subjective thing. So we are not comparing apple to apple. We are just comparing as the cost perceived by the end user. So this is not cost as in so many thousand rupees or so many lakhs rupees. This is based on the comparison cost, where for a typical application, a gantry would cost lowest. Will have the lowest flexibility. So this goes exactly the reverse way, where because it's high cost, the flexibility is high for the solutions. Where the flexibility is low, the cost is also low. So it limits the number of applications that can be solved or selected, and the manufacturers. Now, this might become some of the limiting factor if we just go back to this slide where we've got, I'll quickly bypass the animation, which, sorry for that, there's no way to bypass the animation. Let's just do a recap. Uh, there are less manufacturers out there for gantry. Issues with the communication protocol, issues with the payload, the environment flexibilities, the speed, the mounting conditions, the accuracy. So now let's make this table more effective with those 8 parameters where the speed is low, where the speed is could be very high. So this gives an initial table of selection where we tick what is the speed, very high, then of course you're looking at these two types of robots. What's the cost allowed? If it's low and medium, we are limited to these two types. If the flexibility we need, we are definitely looking at these three types. And if the payload, what we are looking at, so the first thing that comes into mind, the payload is 200 kgs. We don't have any options on in these three. They cannot be done. Of course, gantries can done. So just imagine industrial cranes as the gantries, but they are not robots. So we are limiting ourselves to industrial automation in this place. So I think this is the major point. How would we select the robots? This is a typical skill circle or the integration circle, what we need. Now, this will be an interesting turn. We are not only looking at engineering branches here, we are looking at a lot outside engineering as well. So, and this is where the point is that people see robotics is okay, mechanical engineering. No. People say robotics is communication or the EC or IC engineering. No, the robots is many more beyond that, which we will see. So that typically we would see this as a skill circle where it starts with identifying need to the solution to the design. Yes, mechanical engineers, communication engineers come into play where the design happens, and the implementation where there are other aspects happen. So we'll quickly go on to the looking into the need analysis. So typically any industrial robotics solution, we say understand the need. Now this is where non-engineers will come into play, economics and ROI. Any solution on a larger scale will require economics and return on investment calculations. How would they do it if the costing part, if the commercial aspect part is not clear. So not only engineers, this is where we need a lot of management tactics to be used to find out what is the productivity improvement we are doing. There is no technical, this is just the number that before handling this solution, the productivity was 70%, now it's 90%. What is the manpower reduced? Uh, by selecting a proper robotic solution, what is the manpower we can reduce and the cost of that? The third very important and very neglected parameter is the quality improved or the cost of quality. Now, cost of quality is a very subjective aspect. So normally all the people out there who are designing, suggesting, implementing the solution will not go into the cost of quality. What is the cost of quality if the bad quality or substandard quality goes out in the market? So that cost comes into the economics because that will affect the brand, that will affect the perceived value of the brand, perceived value of the company, and so on and so forth. So there are applications where not enough manpower is reduced. The cost of manpower will come as very less, and the ROI people start discussing about going beyond 5 years. But this the parameter quality improved where we need a lot of management tactics to check out and do a due diligence of how do we do the need analysis. And of course, what we covered, what all automation components, software components. A quick examples of these is management skills where you would start finding out what are the advantage on economics of the solution. No engineering needed. Simple financial calculation, no engineering needed. Cost versus price versus profit, no engineering needed. Of course, knowledge of automation components, engineering needed, where we need engineers to estimate this. And of course, standard practices of the application. Again, this becomes an operational parameter. If we are, for example, if we are supplying to a pharmaceutical company, then we need to know what are the practices of the pharmaceutical company. Let's say a pharmaceutical company would need a pharmacy graduates to look at the due diligence of the paperwork or the reports or the automation being handled. So that's where we'll need a lot of pharmacy graduate. So now we are talking pharmacy graduates into robotic solutions. Do we need that? Yes, we need that. If we are looking at nuclear engineering or nuclear plants, we'll need scientists to work with the robots. So that robots will be integrated by scientists or by the engineers, but the actual processes being handled will be a data scientist or a process scientist who would it. So a robotic solution will need a lot many other skills along with it to calculate the ROI, to calculate the effectiveness of the solutions. So that's where we believe that people have the perception that robotics is for engineers. It's not for engineers, it's for many other people. And that's the message we wanted to give this morning. Um, this is the sequence of the solution or the integration. How do we do that? Typically, we iterate. The first step is ideate, make concepts, make calculations. What are the alternatives? What are the interdiscipline iterations? For example, as we said, the communication protocol against payload, against the speed, and then iterate again, which gets the solution out. What are the typical examples here? Is the skills needed, fundamentals of automation, topography, and the landscape, how everything is connected to each other with the various subsystems. What are the feasibility calculations? We are not looking at heavy engineering here. We are looking at narrowing down the alternatives, and then we get on to real engineering, real design aspect. So here a knowledge of all subsystems, a more experienced person who is skilled into various engineering disciplines. Now, a word of caution. Now, knowledge is king in the current world post-pandemic. There are many modules out there into e-learning platforms and online learning platforms, which will teach, which will give throw lights even to younger generation so that they can train themselves for cross engineering fundamentals. So you might not have experience, that's fair enough. Go to these portals, select proper modules which will allow you to learn fundamentals of the topography, how they are connected each other. We are not looking at exact engineering, exact programming, exact calculations. We need integration of various subsystems. So that's where we feel that there is a lot of scope. We'll cover under the opportunities out there in the later slides. Uh, Hardcore design component where we do functional specifications, design mechanical systems, electrical subsystems, design software, screens, and the connect with the ERP systems. We do the DFM, DFA. These are all understandable for the design engineers out there. The typical examples I'll not cover more because this is for engineers, for mechanical engineers, for electrical engineers, using CAD, using panel wiring and standards, using embedded system design, using software architecture, how to do the computing systems, and knowledge of cyber physical safety system. This is the buzzword nowadays, where uh, a robotic system, the physical system is connected to the IT system and sending out a lot of data. So this is a proper engineering, and this is quite fascinating field because it's the real design at the core. Uh, this is also a cross engineering skill circle. Implementation is not engineering alone. Implementation is manufacturing. Implementation is programming, where we are not looking at any of the mechanical or electrical engineering. It's the quality assurance. We're looking at Six Sigma, 5S, and Kaizen practices. Nothing specifically to engineering because that's where people are hired for bringing the quality assurance in place, quality control in place, installation, commissioning, and training. Now, a training requires a lot of trainers out there because if all these robots are installed, they'll fair enough. I mean, people can argue trainers could be engineers, not always so, because there are certain aspects which are always uh, not looked after in terms of the implementation. Uh, we just go into the examples for the integration, in-depth knowledge of manufacturing processes and the tools. We're not looking at robotics engineering now. We are looking at the manufacturing, managing the manufacturing, managing the quality systems, which is becoming taking us to the operation systems, where a lot of management graduates will be used. They might need to learn basics of robotics or fundamentals of robotics. Again, they can go to the online portals, find out proper courses which will give them just enough knowledge so that they understand the quality system critical aspects and use those quality systems. So uh, moving further, uh, all things that robots. Now, what is coming out there? Uh, According to our team, according to our experience, industrial robots will be there, will not replace in next 20 or 30 years. What is coming out there as the emerging sectors are service robotics, uh, which could be a mobile, which could be screen based, which could be stationary, but for example, all the airports now have got automated check-in and automated baggage systems. Uh, we would call that as service robotic systems. All the hospitals post-COVID era has become a lot of drug delivery systems, a lot of sample delivery systems, a lot of sensors and subsystems to assist the doctors and the patients. The major skill to be checked is the AI and the machine learning here when the robotics are used in the next phase. So we are not looking at just robotics engineer. Now we are looking at the data science. We are looking at the machine learning patterns. We are looking at different sorts of engineering because now we have a lot of data connected things. Of course, drones in terms of mobile and air-based robots, where we've got the last mile delivery and surveillance becomes now a key parameter. We have heard news about drones being used for COVID protocols, maintaining and doing the surveillance, doing the checkings, uh, and of course the inspection and maintenance on underwater and the high altitude lines, where the navigation and guidance becomes the next parameter. And then just here Tesla's out there where Tesla is an automotive vehicle, but we just heard Elon Musk saying they are the latest robotic sentinels mounted on wheels. So that's the proper way to put it, where the technology is going beyond industrial robots. So and we imagine industrial robots will have AI and machine learning, a lot of navigation and guidance when mounted with the automated guided vehicles or the mobile robots. Again, going forward, the path forward, what we see is mobile robots where we have a lot of AI, and the fleet management where three or four or five mobile robots or 10 mobile robots work towards a common function, augmenting the human operations. Cobots again augmenting, assisting the intelligence of the human nature, maintaining the safety of the human operators, and of course, service robots. We covered well covered post-COVID era. So these are the path forward going into the robotics. A very interesting slide. This can take more than 3 hours of discussion. The market opportunities where we are looking at. So we are not looking at only engineers. If anyone out there in the audience looking at the opportunities, career opportunities, or anyone out there in the audience giving advice to the young generation for the market opportunities where they should look at, these are the sectors they should be looking at. These are the happening sector. Of course, this is very a generic statement, and everyone would agree with it that automotive is the future. Now, we are not looking at automotive just as petrol and diesel engines. E-vehicle is also one of the booming factor here. Electrical and electronics, of course, that goes with automotive, cell phones, televisions, and mobile technologies. Healthcare and pharmaceutical, all-time favorite, where the COVID has made it more important or the more critical. Food and beverages, of course, COVID has seen a lot of food manufacturers doing their production 30% plus. And that's where, and the classic sectors are metals and machinery. So these are all the sectors coming up in robotics that will require not only engineering, that will require a lot of management trends, that will require a lot of quality control, and so on and so forth. Uh, of course, the solution wise, what we're looking at, these are the keywords people should find out for a job. Keywords looking for better career opportunities, keyword operating for better solution giving or giving a solution out there in the market. So this applies to manufacturers, integrators, engineers, uh, upcoming management trainees who would like to go into these applications, or companies looking into going these directions. Uh, some fancy number, of course, this was 2019 where 21 billion slated. This I think this number is already old, and we are looking at a much bigger CAGR and much bigger number, 66 billion US dollar. That's the market of industrial robotics. And in logistics and adopting the industrial robots. So these are the trends which are boosting. And if anyone is looking at the career solution selling or career forward, growing their career, these are the trends we should be looking at. I think we are approaching a good on the webinar. I'm restricting, trying to restrict on 45 minutes slot, and requesting all the audiences to look at the social media handles and the channels out there. Follow us on for more free webinars and more announcements on the latest modules coming up. So we have a few announcements to be done today, and the our application out there is hosting so many such modules and the courses which will make uh, job ready, skill ready courses. I'll open the floor for any question and answers. And thank you very much for your time. It was a pleasure talking to you. Just a small announcement: we have launched a detailed course on industrial robotics. Anyone wants to subscribe or spread the word around into your friends and families and professional world, look forward to see people subscribing to these courses. And there are a series of courses coming up On to the Adapt Me modules, where we will have a detailed approach on video, audio, and from the assignment courses, along with free webinars being aired every Saturday on various topics, not just industrial robotics. We do have a lot of management courses. We have a lot of webinars on cryptocurrencies coming up next month. We have a lot of webinars on financial awareness, international business, sales, and so much more. So, uh, a floor is open to the questions, everyone. Thank you. There's a good question that a mechanical engineer holding master's degrees in design adds some skills. I would say look at the skill metrics on just a moment. If you are looking to the future, these are the skill metrics you should be working on along with the design, because you would already have the design skills on board, where uh, AI, how do you use the data, how do you use the machine learning, how to use the communication, signal processing, navigation, and guidance. Mobile robots is the upcoming trend. This would add a lot of flavor to your existing good knowledge. I hope I have answered that. Any further questions? Kindly raise your hand or put the message on the textbook, and the organizers will unmute you. We will be able to unmute so that you can also discuss and speak. If there is no other questions coming up, it must we'll spend a few minutes on the mobile robots, because that's where we see a lot of traction coming on. And next further few webinars, we also intend to do it on the uh, path forward, which is the mobile robots, collaborative robots, and the service robots, which is the and which also requires all the skills of industrial robotics, as well as the mobile robotics, as well as the new skills coming up. See, that's a good skill to add the. I agree. The good skill to have the Python and the data science skills to be added, because that's going to be the future along with the industrial robotics. For the audience out there, we would have this webinar listed on our YouTube channel. So feel free to subscribe, feel free to share this webinar and the series of webinar happening onto your friends, family circle, so that more awareness goes out there. And we will be happy to help individually if anyone wants to connect to us on the social media handles, and our email addresses, which is info@adaptme.com. We would aim to give a neutral, unbiased advice to how to go forward for the various skills needed for career opportunities. That's what AdaptMe is about, where we say education upliftment. So that's we would always strive for. If there is no other questions, I would say we will quickly go on to the conclusion and finish the webinar. I Once again, thank you all the participants for your time out there this Saturday morning in the festival time. Wish you very happy Janmashtami and good festivity around. Thank you very much.